Wireless VR, or specifically wireless PC VR in ultra high resolution, that is something that at least I have been waiting for since the early days of virtual reality. As of today, in 2024, it's finally here, it's better than we hoped for, and it's made possible by Pimax. Hi everyone and welcome back. Today I'm going to tell you about my deep dive into the Pimax 60G Airlink wireless innovation powered by a 60 GHz Wigig module on top of a Pimax Crystal VR headset. We're talking about true wireless PC VR at native crystal clear resolution, at 90 Hz and basically zero latency. Yeah, I know how this sounds, but trust me, it's real. I guess you have seen the Pimax Frontier just recently, a super exciting event announcing several new VR headsets coming out this year. The Crystal Lite, for instance, with unbeatable price to performance ratio, with high-end specifications and crystal clear visuals for an affordable price. Simply a no-brainer for mainstream VR gamers. But hear me out, if you already have the Pimax Crystal headset, you are not left behind. Because apart from eye tracking and a few other features, what Crystal specifically supports while the Crystal Lite does not is the game-changing 60G Airlink wireless VR solution from Pimax. And this is a big deal, bigger than I ever expected. Although wireless VR is not a new thing in the industry, but a lot has been done to technology to match today's PC VR standard. You may remember me being one of the first VR geeks on YouTube, reviewing and playing around with the TP Cast wireless solution using both the original HTC Vive and the Oculus Rift. For me, this was an eye-opener. PC VR would never be the same again without being cordless. But then, the panel technology did quickly catch up, surpassing what the image signal transmission was capable of over existing wireless protocols. Pimax last generation wide field of view headsets got stunning dual native 4K panels, while the other brands also went high resolution. And suddenly, true wireless PC VR was not possible anymore without huge compromises due to the technology not advancing in the same pace. As kind of a substitute, the VR image streaming over Wi-Fi became a thing of some brands, but these solutions introduced noticeable image compression, higher latency, and a significant step backwards in terms of rendered resolution and visual clarity. And sure, there are a few wireless solutions existing as of now, but none of them provides the true experience of what PC VR stands for or actually deserves. Today, everything is about to change. The new Pimax 60G Airlink module uses the latest technology to bring us a true cordless PC VR experience. And this time without compromising on resolution, image clarity, refresh rates or latency. Now, I do have an engineer degree, although I'm not a high-end Pimax engineer involved in the development of the hardware, so today I'll mainly show you my test results and what I think of it, instead of going deep into the technical side of things. To achieve an ultra-high resolution combined with high refresh rates and ultra-low latency, Pimax has done some magic. Yes, you see, the wireless Airlink is utilizing foveated transport and split rendering techniques with near-to lossless compression. This is done to lower the extreme high bandwidth requirements to transmit a high resolution video signal over a dedicated protocol running at 60 GHz network. It's also using the built-in eye tracking to achieve this, and similar to how dynamic foveated rendering works, the wireless image signals is split into areas where the center view part is rendered in full native resolution, always providing you maximum clarity and sharpness. The Crystal headset renders a native resolution of 2880 by 2880 pixels per eye, and the Pimax engineers worked for years to find a way to keep that native resolution and the same 35 ppd or pixels per degree over the wireless protocol. And they obviously made it, because with the Airlink module, VR games are now running at the same native resolution of 2880 by 2880 pixels per eye without any upscaling or downscaling, and that is on paper 16.5 million pixels in total wirelessly. Furthermore, the refresh rate modes currently available are 60, 72 and 90 Hz in wireless mode. Yeah, you heard it right, up to 90 freaking hertz. Depending on what refresh rate mode you choose, a different compression level is applied with its own algorithms to nearly max out the bandwidth limits of the 60G Wigig protocol. And this by maintaining a super low latency, meaning no lag or no delays whatsoever, and basically zero latency on the built-in tracking of the headset and its controllers. And I can testify it just works, and I'm proving it here. During my 2 weeks of stay at the Pimax headquarters up front the Pimax Frontier event, I spent dozens and dozens of hours testing and evaluating the Wigig or Airlink solution. To be honest, this was actually the most exciting part of my trip. I was given enough of time to try most of my favorite VR games running wirelessly. Of course, I only did record a few gameplays for this video. Specifically, I chose to record popular games like Beat Saber, Pavlov, Pistol Whip, Half-Life Alyx, Super Hot, and some various sports games and a few others. I spent a lot of time playing fast-paced VR titles. I think these VR games are some of the best picks to properly evaluate the wireless technology and to potentially challenge the tracking capability by putting the wireless VR transmission and its latency into tests. Since the 60G Airlink module is still in development and it's still being improved day by day, I must admit it's not yet perfect. Running at native resolution in 90Hz, I did notice some very slight controller tracking latency, mainly when playing a table tennis game. I heard from the team that this is being worked on, so I'm not really worried. In fact, at 60 and 72Hz, this problem didn't exist. Other than that, I really tried to find other latency issues in fast-paced first-person shooters, Beat Saber and Box VR for instance, especially at 90Hz. And believe it or not, but I just couldn't find any flaws really. After a short moment of playing each game, it kind of hit me every time that I tend to totally forget I was playing wireless VR. If you really pay attention and look specifically for signs of compression, you may actually see some in the peripheral view, especially at 90Hz. It's not really obvious artifacts or image flaws, but some slight blockiness or jagged edges could sometimes be spotted in the outer fovea areas, at least when I tried some fast or very fast head movements. Still, this is way better than compression artifacts related issues I have seen testing other wireless solutions, including the Quest 3 Airlink. All in all, the resolution and clarity is just incredible while playing wireless, just like it is when playing with the Crystal with the cable connected. Brightness levels are the same as before, local dimming does its magic for black levels, and the colors are just as accurate. To my surprise, I could not spot any color banding, which I initially expected, due to the image signal compression maybe affecting the color range, but it didn't. I also tested the Real-O virtual environment in SteamVR, and not so surprisingly, the text was super sharp and easy to read, identical to how Crystal performs with PCVR when using a cable. The field of view is still the same and the colors are popping. The audio is also transmitted through the wireless interface, and I could not tell any additional delay or latency during my days of testing. Although this is not the final product, I'm super impressed by the wireless performance, making me totally forget that I'm not corded anymore. Okay, I know what you're thinking when you're looking at the gameplay recordings. You do probably see a cable going from the headset, right? Well, let me explain. Currently, the Pimax team is working hard to improve the power management and sufficiency of the 60G Airlink dongle receiver which is connected to the Crystal. The dongle is powered by Crystal's replaceable and rechargeable battery attached to the back of the headset, and it does draw some power indeed, at this point probably more than it's supposed to. This is the reason why I was running all tests having a 20,000 mAh power bank connected with a cable to the USB-C port located on the right side of the Crystal. Not only to extend the battery life, but also to provide the dongle with some additional power and make it work fully stable. In fact, it is possible, and I tested this, to run Airlink without a power bank connected, but as of today, Pimax recommended me to use the power bank to make it fully stable, so there you have it. Now, let's briefly explain how it's all connected on the hardware side. The 60G Airlink wireless solution bundle consists of a transmitter and a receiver. The Airlink transmitter is connected to your PC's graphic card and its HDMI output. The cable has a full-sized HDMI connector on the PC end side and a mini HDMI connector on the other end for the transmitter. By removing the small lid on the back side of the transmitter, you can attach and safely lock the mini HDMI cable. Besides that, there's also a USB-C port on the transmitter which you use to connect to your PC with a USB-C cable. The transmitter can either be standing upright on a surface like on a shelf or a table maybe, or it can be attached to a wall mount, tripod or whatever by removing the bottom foot of the unit. Underneath there is a standard 1/4 of an inch screw hole compatible with most wall mounts, tripods and connectors. The 60G Airlink receiver, on the other hand, is a tiny dongle that is easily clipped onto the rubber top strap of Crystal and then connected to the headset's micro HDMI input at the top. In short, the PC is sending the compressed HDMI interface video signal from the GPU to the Airlink transmitter and then wirelessly to the Airlink receiver. How the headset's tracking data is transmitted to and from the PC is still a bit unclear to me, but I can definitely tell that it works as intended, using only the receiver and the transmitter. As with any other 60 GHz transmission, the signal relies on a clear line-of-sight transfer. This means that the Airlink transmitter needs to constantly see the receiver while connected to the Crystal headset without anything interfering the signal in between. This also means to achieve an optimal signal, the transmitter should be located pretty high up in your room, always slightly looking down on the receiver sitting on top of your head. This way, the risk is minimal that anything comes in the line of sight, potentially breaking the signal. During my days of testing the 60G Airlink, I don't remember the signal ever being lost even once while playing all those VR games wirelessly. The VR image was extremely stable actually, despite bending down, sitting on the floor, doing fast turns or holding up my hands that theoretically could block the signal. I even tried laying down flat on the floor while playing Half-Life Alyx and the connection was never interrupted or weakened in any regard. I could not see any increased compression nor any video blackouts while doing all these maneuvers. As for the wireless transmission range, I have not heard about the exact limits of how far the 60 GHz signal can transmit the data, but while standing within approximately 4 or maybe 5 meters away from the transmitter, the signal was never lost or degraded, not even once. It's pretty impressive, I must say. You may also wonder how this is all run on the software side, and I will go deep on this topic once I get my new sample coming in here to my office here in Sweden very soon. And there are some things I forgot to record for this video, but in short, you boot up the Crystal headsets into the AIO or standalone mode, then start up the Airlink application and then just click a connect button. On the PC side, you run the Pimax PC client just as usual. The connection procedure takes between maybe 5 to 7 seconds, and once the wireless connection is established, you'll instantly see the VR view in the headset and the HMD is automatically detected by the PC client software. Now, as I said, the Pimax wireless 60G Airlink solution you're looking at is not the final version of the upcoming product. Currently, it's still being tweaked on and constantly improved both hardware and software wise. I'm pretty sure that upon release later this year, we will see the 60G Airlink being an even more mature product, more optimized, even more stable, and maybe including additional features I haven't even tested yet. However, what I've seen so far of the Pimax 60G Airlink during my stay at the headquarters is nothing else than mind-blowing. I think just a year ago none of us were really expecting true PC VR run wirelessly at native 2880 by 2880 resolution and also in 60, 72 and 90 Hz. It's for sure a huge milestone for Pimax getting the Airlink available to all Crystal owners this year. This might be the most technically impressive product the company has developed so far, at least in my opinion. From what I have tested and seen so far, the 60G Airlink turns out to be a fully working, highly impressive and stable and affordable wireless PC VR solution that performs way above my expectations. Oh, and by the way, you can already now reserve the 60G Airlink module on the official Pimax Store. For $299 US, I think it's a no-brainer, and on top of that, current cluster owners even get a $50 US discount. If you don't have a Pimax Crystal yet, you may also get the full bundle with a shiny new crystal and the 60G Airlink module. Alright, I promise to keep you updated. I'll do new videos, tests, benchmarks as soon as my 60G Airlink module arrives here at my office in Sweden. Meanwhile, thank you so much for watching. I hope you really enjoyed this video and see you in the next one.